Hi everyone, how are you doing? Am I audible and visible to everyone? Good afternoon, Abhiram. Good afternoon, Yarika. I hope all of you are doing fine, and I am audible and visible. Okay, so as I always say before the class, good afternoon, Tanu. It's not sir, it's sir. Anyways, I know, stepping mistake. Okay, so keep your videos off, and if you have to send any message, you send me on the ID of Astik. That is the ID that I look at for your messages. Now, I think in the last class, we had discussed graphs in 1D motion. We had discussed position time graph in that. And we start today's class with problem number 21 from your solved examples. Problem number 21. And what does this problem number 21 says? Which of the following graphs represents uniform motion? Uniform motion. So all these graphs are S, which is probably displacement time graphs. In your exams, the question comes like this: displacement time graph. But remember, it is more a position time graph rather than displacement time graph. To take it as position time graph. So there are 4 position time graphs given to you. You have to tell me which graph represents uniform motion. When you talk about uniform motion, what is meant by uniform motion? We must know that uniform motion means motion with uniform velocity. I hope you understand this. Uniform motion means motion with uniform velocity. So which graph represents motion with uniform velocity? And I'm waiting for your answer. Which graph represents motion for uniform velocity? Niharika gives an answer, and the answer is definitely A. How is the answer A? Why is the answer A? How is the answer A? How is the answer this graph? Niharika, can you tell me? I'll ask you to unmute. Niharika? Where is her? Okay. Yes, Niharika, tell me, why is the answer A?
Sir, can you hear me?
Yes, better, loud and clear. Tell me.
Sir, because the graph represents the straight line.
Graph with a straight line. Okay.
It means it is with the constant slope.
It's the constant slope, and therefore slope of position time graph gives us velocity. So A is the answer. Now, can you tell me, Niharika, what is the problem with graph C? It is also a straight line graph. What is the problem with this one? What is the problem with graph C, Niharika? Again, I have asked you to unmute. Okay, tell me, Niharika. What is the problem with graph C? Graph C is also a straight line graph. What does it represent? Anyone?
Sir, the body is at rest and the slope is 0, sir.
The body is at rest and the slope is 0. That is what graph number C represents. What does graph number D represent? What does graph number D represent? Anyone would like to tell me what does graph number D represent? Who will tell me? Siddharth, Tanu, who will tell me? Vinay, Tarun, who will tell me? What does graph number D represent? Do we understand what does graph number D represent? Please raise hands. If you understand, please raise hands. What does graph number D represent? No one knows it? Okay, then I'll tell you what does graph number D represent. If I call this point, okay, Abhiram has raised hand, so probably Abhiram knows it. So Abhiram, I'll ask you to unmute and tell me what does graph numbers D represent. Yes, Abhiram, tell me.
Sir, I think it would be like moving till some time and then it will stop, what we say, it will stay in the same position.
Okay, beta, you are partly right. If I call this point as if I call this point as A, and if I call this point as B, if I call the third point as C, from A to B, the velocity, the slope is positive. That means the body is moving in the positive direction from 0 to some point. Let me call this point as, let us say, 2 meters. So it moved from 0 to 2 meters. From B to C, the particle is at 2 and started moving towards 0. Am I clear? How does the motion feel? From A to B, if the particle has moved from 0 to 2 with a constant speed, from B to C, the particle has come back to the origin with some constant speed. Am I clear with this? Can I have some raised hand that we understand it, sir? How the particle has moved? A to B, constant velocity. B to C, constant velocity. A to B, it has moved from 0 to 2. B to C, it has moved from 2 to 0. Okay. Okay. Then I can ask you this one, problem number 23. Problem number 23. From the following displacement time graph, as I told you, beta, always, they will call it displacement time graph, but you don't get confused. It is a position time graph. From the following displacement time graph or position time graph, find out the velocity of the particle. Remember, the displacement time graph is drawn in a different way. Displacement is here and time is here. That is the catch. That is the catch of this graph. Normally, the graph that we had seen was different. What will you call this graph that they have drawn? They have called it displacement time graph, but is it actually displacement time graph, or is the name different? The name should be different, or is the name correct? What do you think? Is the name correct? Displacement time? Or the name should be different? Tell me, anyone. Name should be different. Niharika says name would be different. Then what would be the name, Niharika? What would be the name? What would be the name of this graph? Okay. So I will try to do this here. I hope we have all seen the graph. So how does the graph look like? How does the graph look like? This is, I think, question number 23. Question number 23. How does the graph look like? So I have here, I have this. I have drawn displacement here, and I have drawn time here. Displacement, this is a wrong graph, drawn wrongly, but let us assume that it is like this. And the graph is like this. It makes an angle of 30 degrees with the x-axis. Remember, on the x-axis, we do not have time, but we have displacement. Now, the actual graph should be like this. The actual graph, which we all know, should not be like this. It should be like this. Time must be here and displacement must be here. Time is plotted. So the name of this graph is time displacement graph. But the graph that I have drawn is a displacement time graph. Displacement is plotted on the y-axis and time is plotted on the x-axis. If I can find out the value of this angle theta, and then I find tan of the angle theta, this tan of the angle theta will give me the slope of this graph, which is constant, and the slope of the position time graph will give me the velocity. Yes or no? Yes. Okay, so this angle is BC because 60 plus 30 has coming becomes of this angle 60 degrees is root. Niharika and Abhiram are there. What about Siddharth, Tanu, Tarun, Vinay? Do you have any doubts, beta? Please ask. I think, okay, Tanu is there, Tarun is there. What about Siddharth and Vinay? Siddharth is also there. Vinay is not using his mic. Please, Vinay, come in the class if you are there. Okay, so that was the answer to this one. Let us do one more question on this, and then I'll do one question of my own. Now, this is problem number 22. It has come in so many exams, CPMT, MPPT. It has also come in your NEET exam. I am just showing it to you. I think you have the file with you. This is solved example from your file. This question has come in CPMT. There was some time where it was known as CPMT, your NEET exam. It also came, I think, in the NEET 2020. Same question, similar question, exactly same wording. It came in your NEET 2020. So let us now solve this question and see if we can do this. So what does the question read? The displacement time graph of two particles A and B are straight lines. So we have A and B ka straight lines. One is inclined at an angle of 30 degrees. The other one is inclined at an angle of 60 degrees with the time axis. What is the ratio of their velocities? Two particles moving. The displacement time graph is plotted. It makes an angle of one angle. Particle A makes an angle of 30 degrees. Particle B makes an angle of 60 degrees. It is asked to find out the ratio of velocities. Can I have some answers here? Can anyone tell me some answers? Give me some answers. Niharika has come up with an answer instantly. Good work, Niharika. That is the correct answer. Let me give one more minute to everyone to understand how this answer is achieved. Is actually solved in the book, solved in your notes, so you can just see the solution. But I won't use the solution. I will be solving it on the whiteboard for you. The solution is already here. I will be solving on the whiteboard for you guys. So here comes the solution. Let us first draw the graph of these two. So let me first draw the graph. I think the screen is visible to you now. This was question number 22. Question number 22. So let us first draw the graph. So this is my displacement time. Time is plotted here. Displacement, let us say X is plotted here. This green one, let me say, represents the motion of body A. The graph is inclined at an angle of 30 degrees. The second one, let me draw it as pink, is B, and it is 60 degrees. We have to find the ratio of their velocities. So basically, we are supposed to find out velocity of A divided by velocity of B. We have already done in the previous question that to find out the velocity, we have to find the angle with the x-axis, with the time axis, and find the value of tan theta. We'll apply here. To get the velocity of A, we have to find the value of tan 30. Do we understand this? Can I have some raised hands so we understand? Velocity of A will be tan of 30. Only two participants. Why only two students apply? Where are the rest? Tanu, where are you? Vasant, Vinay, please participate. Okay, so this will be tan of 30, which is velocity of A, divided by velocity of B, which would be given by tan of 60. You have to divide tan of 30 with tan of 60. Tan of 30 is 1 divided by root 3. Tan of 60 is root 3. So my final answer would be 1 by 3. Am I clear with this question? Raise hands. Show of strength will make me happy. Yes? Great. Great. I'll do one more here. And now we will do this question. After that, I will move on to my created question. Again, this question that you see has come in a previous year NEET 2018. The values may be different. I think the values even were same. So this is problem number 24. Problem number 24. The diagram shows the displacement time graph for a particle moving in a straight line. As you can see, the particle is definitely moving in a straight line. The average velocity for the interval t is equal to 0 to t is equal to 5. So the graph is given to you. You have to find the average velocity from 0 to 5 seconds. Remember what is average velocity. Again, the graph is wrongly represented as displacement time graph. It is not displacement time graph. It is position time graph. As you can see, x is plotted, the position is plotted. So it's a graph of position with time. You have to find out the average velocity. I hope everyone has seen the graph because I'll be now moving on to my whiteboard and we'll be solving that question. In the time that I make the transition from here to the whiteboard is the time that you have to solve this question. As I've already told you, beta, I would be sharing all these files with you in the PDF format. Previously, I was using Zoom ka thing, but sometimes I was not able to save them. Sometimes they used to disappear. Now they're all in my laptop. So don't worry about the notes part. You will be getting them. You can write the notes at your own time. While in the class, please pay attention to the class and write running notes in rough copy, and then you can share them while you are looking back at the lecture. I would suggest that in the evening time, you go and have a look back at the lecture of today's class, and then you make your good notes with all the questions and everything. So that was my suggestion to you all. I would keep on giving you good suggestions. You might like them, you might not like them, but it's my job to tell you what is correct and what is not. So now let us come to question number 24. Anyone with an answer to this? Question number 24. What is the average velocity? The question was already solved there. The question was already solved there. I'm trying to use this. Let me see how good or how bad I use it. This is good enough, I think. Okay, so this is my time axis. This is my x-axis. That was the graph. The time axis is going a little teda, but still okay for first timers. Then I have this line coming like this. Then I have this line going like this. Okay, here the time is 0, here the time is 2, here the time is 4, here the time is 5, and then we have a negative x-axis here. Here the position is, I think, -5, and here the position is 20 meters. Everything is plotted in meters. Here everything is in seconds. So the question is very simply, what is the average velocity from 0 to 5 seconds? Average velocity from 0 to 5. Anyone with an answer? Anyone who understands how to do this? Now, average velocity was total displacement divided by total time. Do we remember this? Total displacement divided by total time. That means you have to find out the final position. Final position. Instead of writing it as RF, since it is motion in one dimension, the particle is moving along x-axis. I will write it the final position on x minus initial position on x divided by total time. Now I look at the final position xf. The final position is at 5 seconds. At 5 seconds, as you can see here, I've highlighted it. At 5 seconds, where is the particle? The final position is -5. Oh, it's not -5, actually it is -10. I have wrongly written it. Let us do it by -5 since I have written this. So final position is -5. So I will write -5 here. Final position is -5. Minus, what is the initial position? Look at the initial position at time t is equal to 0. At time t is equal to 0, where is the particle? The particle lies at the origin. The position is 0. So x initial becomes 0 divided by how much time it has taken. Time is from 0 to 5. So the total time becomes 5 seconds. So our answer becomes -1 meter per second. That is the answer. If I change this from -5 to -10, which is the original question, you will get, instead of -1, you will get the average velocity as -2. Am I clear with this concept? Do we all understand this? How I found out the average velocity? Can I have some raised hand that we understand this, sir? Tanu, Tarun, Vasant, Vinay, do we understand this, beta? Okay, great. Now, in the same question, let me make my own question and see how can get answers to this one, so that the concept becomes pretty clear in your head. This was question number 1. Now let me make another question, question number 2. What is the average velocity from 0 to 2 seconds? What is the average velocity from 0 to 2 seconds? So look at the initial position, look at the final position, and give me the average velocity from 0 to 2. Niharika has come up with an answer. Niharika, remember, everyone remember, velocity, displacement, acceleration, they are all vectors. When you talk about vectors, you must remember that vectors have magnitude as well as direction. If you're only talking about direction, you are killing vectors. Please don't kill vectors. We are not killers. Vectors must have direction. So look at this initial position. 0 is the initial position. At the final position, the value of x. So I have to find x final minus x initial, position final minus position initial divided by the total time. What is the final position? What is the final position? From 0 to 2 seconds. At 2 seconds. At 2 seconds, where is the particle? The particle is at 20, plus 20, beta, plus 20, plus 20. The final position is plus 20. Initial position is at 0. 0 second, it is at 0. Minus 0 divided by total time is 2 seconds. So the answer becomes plus 10 meters per second. The answer is the answer. What is the significance of this plus sign? Anyone? Position on y-axis does not mean that the particle is moving up and down. Look at the particle towards right. Am I clear? Am I clear? Am I clear? Yes, positive x-axis is right, Nihari. Now my third question here. If I look from O to A, which is from 0 to 2 seconds, if I look constant velocity variable, is the particle moving with constant velocity or is the particle moving with variable velocity? Velocity is constant. Now if I have to ask you, in between you will have 1 second. What is the velocity at 1 second? Velocity at 1 second. At 1 second, the particle is somewhere in between. Niharika gives me an answer. Again, the answer. Position time graph is a straight line, so velocity is constant. So what is the will be same as your instantaneous velocity. So you got the average velocity as plus 10. So velocity at 1 second is 1 here or here or here or here. Am I clear? Can I have raised hands? I only have one. Have you understood? Great. Great. Now let me make one more question here. Looking at segment C, C segment from 2 to 4 seconds. What will be the velocity from 2? Answer -5, Niharika, that is not correct, I think. So again, what you got to do is you got to look at the first position from second. It is at position number 8 and behind this. Okay. Now I could ask you another question in a NEET exam. The graph is given to you. What is the velocity from 2 to 4? Is the velocity? What will be the velocity at 3 seconds? Get 3 with an answer. So velocity at 3 seconds is same as the average velocity. Same as the average velocity was minus 10 4 to 5 seconds. 4 to 5 seconds. The final position. This would be your C in this case would be your position initial. Can I have your answers now? We'll get answer now. Average velocity from 4 to 5. So you can write position at 5 seconds, which is the final, minus position at the velocity from. Am I clear with this concept? Anyone with a doubt, please raise your hands better. For the average velocity, we have found out the total displacement and divided it by total time. To find out total displacement, we have subtracted the initial position from the final position. Now I would like to raise your hands for those students who have any doubt in this question or in any question based on graph that we have done till now for the position time graph. Because if we have no doubts, we'll move on to the next type of graphs, which are known as velocity time graph. Velocity time graphs. So we will be moving on to velocity time graphs if you don't have any doubts here on this one. I'll give you time to think. 1 minute, 2 minutes, else I will move on to velocity time graphs. Well, I don't have any raised hands, so I'll assume that we have understood this. So now we'll move on to velocity time graphs. Now we'll first write the notes. First note, note number 1. What will the slope of velocity time graph give us? What would the slope of velocity time graph give us? Slope of velocity time graph means dv by dt. Derivative, that is the slope. You don't have any doubts on this. Point number 2. What is point number 2? Integration of v dt. It is the integration of v dt. What does area under velocity time graph give us? When you integrate velocity with time, go back to your maths class. Derivative of velocity with time gives me acceleration. Integration of velocity with time, integral of v dt gives me what? It gives me the displacement of the particle. So if I have the velocity time graph, if I integrate it, or in other words, I find the area under velocity time graph, it will give me displacement. It can also give me the distance traveled. It can also give me the distance traveled. Once we draw a graph for velocity time, we'll understand how will we get displacement and how we will get distance. So in a position time graph, we only could get the velocity by the slope, and we got the displacement by subtracting the initial position from the final position. So we got two things from position time graph. One is the displacement, other is the velocity. From velocity time graph, we'll also get two things. One is acceleration, which is area under the graph. The other thing, one is acceleration, which is derivative, slope of the graph. The other is displacement or distance, which is the area under the graph. Let us now do this one by one. Let us first move on to the first type of graph, which would be the simplest of all. And the simplest of all would look like this. The simplest of all would look like this. Simplest of all would look like this. I would be plotting time here, and I would be plotting v here, velocity. The particle might be moving along x, the particle might be moving along y or z, and always plot velocity on the y-axis and time on the x-axis. What could be the simplest possible graph, anyone? In this category, what could be the simplest possible graph in this category? And anyone with an answer, what would be the simplest possible graph in this category? The simplest possible graph would be a graph which is a straight line which is parallel to x-axis. That is the simplest possible graph. And I've plotted some things, T1, T2, initial position is A, final position is B, and the particle is moving from A to B. Now let us summarize the main points from this graph. What are the main points that we can see from this graph? Point number one. Point number one. I'll ask you a question and you give me the answer. That will be point number one. Is the particle moving or is the particle at rest? Niharika comes up with an answer straight away. It is at rest. Remember, beta, this is not position time graph. This is velocity time graph. Velocity time graph is parallel to x-axis, t-axis. That does not mean the particle is at rest. It means the velocity is constant. If it is having constant velocity, which is not zero, it cannot be at rest. It is in motion. The particle is in. The particle is moving and the particle is in motion. Am I clear? Am I clear? Particle is in motion. Am I clear? Raise hands that we understand this, sir. This is not a VT graph. Position is changing. The particle is moving. Number two, what about the velocity of this particle? Is the velocity constant or is the velocity changing? Is the velocity constant or is the velocity changing? Look at the graph. Velocity is constant. Yes, Niharika, velocity is constant. Third point, is the velocity positive or is the velocity negative? Remember, velocity is a vector. Positive or negative means direction. So is the velocity positive or is the velocity negative? We are talking about the direction. Is the velocity positive or is the velocity negative? Your answers. The graph is above time axis. So above time axis, this is positive. If the graph was below time axis, it would have been negative. Yes or no? Yes or no? Please tell me your answer. Yes or no? Yes, Tanu. Welcome to the class. Welcome to the class, Tanu. Velocity is constant, velocity is positive. Great, great. Third one. Oh, this is the fourth one. See, I also make mistakes. Fourth one. What about the slope of this graph? What about the slope of this graph? What about the slope of this graph? Look at the graph. Look at the graph. Tell me its slope. What about the slope of this graph? The slope is 0 because the graph is parallel to time axis. Yes or no? Yes or no? Let us talk about the fifth point. If the slope is 0, what about the acceleration of this particle? What about the acceleration of this particle? See, you can understand it from here also. Velocity is constant, velocity is positive, velocity is constant, velocity is constant. So what about acceleration? What about acceleration? Acceleration has to be 0 because velocity is constant. Am I clear? Can I have some raised hands that we understand this, sir? That we have understood this VT graph and we have understood the basic points of this graph. I only have one raised hand. Abhiram, Tanu, Tarun, Vashant, are we there? Okay. Great. Great, everyone. Okay, let us now move on to the second type of graph. In this category, we'll have the second graph. And we have this one. Okay. Let me have this green graph. The green graph first. No, green one. Green is good. Okay, let me talk about this green graph. I have time plotted here, velocity plotted here. Let me call this point as A. Let me call this point as B. Particle is moving from A to B. Let us discuss this graph. Point number one, is the body moving or is it at rest? Is the particle moving or is it at rest? Definitely the particle is moving because velocity is not 0. Particle is moving. Number two. Is the velocity positive or is the velocity negative? Velocity is positive because it does not go below time axis. Velocity is positive. Number three. Is the velocity constant or is the velocity variable? Is the velocity constant or is the velocity changing? Velocity is constant, no Niharika. Velocity is variable. Velocity is variable, it is changing. At point A, the velocity is 0. At point B, the velocity has got some value. At some other point, the velocity will have some other value. V1, V2. Velocity is definitely changing. And hence, velocity is variable. Am I clear? Now, since the velocity is variable, either the velocity is increasing or the velocity is decreasing. What is happening here? Is the velocity increasing or is the velocity decreasing? Is the velocity increasing or is the velocity decreasing? With time, if I move forward in time, the velocity is constantly increasing. Yes or no? Yes, so the velocity is increasing. Velocity is increasing. Now look at the slope of this graph. This graph is definitely a straight line graph. Yes or no? This graph is a straight line graph. Yes or no? What about the slope of this graph? What about the slope of this graph? Is it constant or is it variable? What about the slope of this graph? This is definitely a straight line graph. What about the slope of this graph? Constant or variable? Constant or variable? Slope of this graph. Slope of this graph is definitely constant. Yes or no? Yes. Now, next question. Is the slope positive or is the slope negative? Is the slope positive or is the slope negative? You must see when time increases, velocity also increases. So they are directly proportional. Time increases, velocity increases. So the slope is positive or negative? Yes, Niharika, correct. Slope is positive. Velocity is positive. Velocity is increasing. Velocity is variable. Graph is a straight line. Slope is constant. Slope is positive. Let us now convert everything into acceleration and we'll understand it from many points. What about the acceleration of this? What about the acceleration of this particle? Is it constant or is it variable? What about the acceleration of this particle? Is it constant or is it variable? The acceleration. Is it constant or is it variable? The acceleration. Slope is constant. Velocity time graph, slope is constant. And hence acceleration is constant. Am I clear? Acceleration is constant. The slope is also positive. Therefore, the acceleration is also positive. So here are the points that I have made. Point number 1, particle is moving. Velocity is positive. Velocity is changing. It is increasing. Graph is a straight line. Slope is constant. Slope is positive. Acceleration is constant. And acceleration is positive. Do you have any doubt on this? Please come up. Anyone has any doubt on this? Please come up. Please raise your hands. Abhiram, I'll ask you to unmute. Okay. You don't have a doubt. Okay. So I guess this graph is clear now. I would be saving some time, and instead of drawing a different graph, I will be trying one more graph in the same thing. And now the graph goes like this. Now the graph goes like this. And now I'll call it moving from C to D. The particle is moving from C to D, the blue graph. Can the particle move from D to C? Can I say that this graph is also valid when the particle is moving from D to C? Can I say that? Anyone? If I say that, what is wrong? If I say that, what is wrong? The particle is moving from D to C. I cannot say the particle is moving from D to C because when I'm going from D to C, I am going back in time. I'm going back in time, and going back in time is not possible. So this graph or this particle has to move from where to where? It has to move from C to D. So now let us think about this graph from C to D. Are we ready? Can we have raised hands so that we can discuss all these points? Raise hands, sir. We are ready to discuss. Okay. Tell me what is the first point. Look at the first point. Is the particle moving? Yes or no? Yes, the particle is moving. So we take it. We write it. The particle is moving. Let us jump on to the second point. What about the velocity of this particle? What about the velocity of this particle? Is it positive or is it getting negative at some point? The velocity of this particle is positive. It always remains above time axis. It never goes below time axis, and hence the velocity has to be positive. After some time, if it goes below the time axis, then only the velocity becomes negative. Am I clear with this point? Am I clear? Okay, so velocity is positive for both the graphs. Point number 3, let us come to point number 3. Is the velocity variable or is it constant? Is the velocity variable or is it constant? As you can see, the velocity is variable because it is constantly changing. At point C, the velocity is something. At point D, the velocity is something else. That means it has changed and hence it is variable. Are we clear with the 3 points? Let us come to point number 4. Is the velocity increasing? Is the velocity increasing? No, the velocity is decreasing. Velocity is decreasing. At C, the velocity is very high. At D, the velocity is very less. Velocity is decreasing. Great. So the velocity is decreasing. This thing has changed from the previous case. Is the graph a straight line graph? Is the graph a straight line graph? Yes or no? Yes, you can see it's a straight line graph. What are you asking? Let us talk about the slope of this graph. Is the slope of this graph constant or is it variable? Is the slope constant or is it variable? Sir, it is a straight line graph. What are you asking, sir? It is a constant slope graph. We know it. Okay, beta, we know it. Listen to me carefully. Eyes on the whiteboard. What about the slope of this graph? What about the slope of this graph? As time increases, what is happening to the velocity? Velocity is decreasing. Velocity is decreasing. So what about the slope of this graph? Is it positive or is it negative? Yes, beta, it is negative. Because when time increases, velocity decreases, so the slope is negative. Am I clear with this? Am I clear with this? Okay. What about the acceleration? Now let us convert everything into acceleration. What about the acceleration of this particle? The acceleration is constant because it is a straight line, but the acceleration is negative. Velocity is positive, acceleration is negative, velocity is positive, acceleration is negative, and that is why your velocity is decreasing. So that was all about these velocity time graphs. Am I clear? Do we understand these graphs correctly? Okay. Okay. Now we also discussed that we can find both displacement and distance from the velocity time graph. So we will now discuss how do we get the value of displacement and distance traveled. Now to get the displacement or distance traveled, we must find out the area under the velocity time graph. So if I want to find out the displacement or distance from time t1 to time t2 seconds, I must find the area. So which area I am talking about? I am talking about this shaded region, which is nothing but a rectangle ka area. So this area gives me displacement. This area, which is shaded over here, gives me the displacement of the particle. Am I clear? Am I clear? This area gives me the displacement of the particle. Can I have some raised hands? Shall we understand this? So this area gives me the displacement of the particle. But again, a very important point has been missing here. Displacement is a vector. It has a direction. So it could be either positive or it could be either negative. So I must also tell what is the direction. Is it positive or negative? Now, how do we get positive and negative from here? How do I get positive and negative from here? Listen to me very carefully. Eyes on the whiteboard. If the area is above time axis, area is above time axis, area is above time axis, it is positive. When will the area be negative for displacement? If I had the velocity time graph like this, and then if I had found out this area which is below the time axis will be taken as negative. Am I clear? What have I discussed here? If the area is above time axis, it would be taken as positive. If the area is below time axis, it would be taken as negative. Can I have some raise of hands, show of strength? Yes, sir, we have understood this, sir. This is clear to us, sir. We have no problem with this, sir. Okay. Last point, not the least one. How do I get the distance traveled? Point number 7. Again, as I told you, from area, I can also get the distance traveled, which is L. Same area gives me displacement. Same area gives me time. Then what is different? That means every time displacement and distance would be same, sir. No, sir. Displacement and area, displacement and distance are not the same things. Displacement is a vector, so that it has a sign, and I have given it positive and negative. But what about distance? Can it be negative? Can distance traveled by a body be ever negative? Answer me, bata. Can distance traveled by a particle be ever negative? No, Niharika. Yes, it cannot be negative. So it is always taken as positive. So for distance, this area is also positive and this area is also positive. So we'll never take negative for distance. We'll find out all the areas, treat them as positive, and find out distance. To finding out displacement, time axis के ऊपर is positive, time axis के नीचे is negative. Am I clear with this point of how to find out displacement and distance from the velocity time graph? Finding out the area, we will get the displacement and distance. Finding out the slope, we will get the acceleration. That is what we have discussed in today's class. We have discussed velocity time graph. Its slope gives us acceleration. Its area gives us displacement and distance. How do we find out? We'll be solving some questions in the next class. I'll be winding off today's class here at this point. If you have any doubts, you can please come up. I would ask you to solve some questions from your notes. I will be showing you your notes. If you can solve these problems which are given in your notes, I would be very happy. The notes are coming right away. We have done problem number 24. You can try problem number 25. Problem number 25. Then we have velocity time graph. Whatever we have discussed, everything has been given in great details. You can make your notes from this. I would be sending you this file. Then there are different types of velocity time graph given. We have discussed most. The curve one we have not discussed. You can read them through this. We'll discuss them in the next class. Probably all types of velocity time graphs that can ever come in any exam, including your NEET, are discussed here. You can go through them. Then there are some sample problems, starting from problem number 26 and going till, I think there are a lot of problems going till 35, 36, 40. I think it is around 39. So solve these problems at home. If you can do them, it's very good. We'll be discussing some of these problems in the class in the next one. I'll be sharing these notes with you. Don't worry. We'll meet in the next class. If you have any doubts, beta, please come up. From my end, the class is over. Take care.